In this video, we're going to go over some tools that we can use when we're solving problems with quadratic functions. So first, a quick review of what the vertex of a parabola is. So the vertex of a parabola is either the highest point of a parabola or the lowest point of a parabola. So if the parabola opens down, it will have a maximum point, and that's what the vertex is. And if the parabola opens up, the parabola will have a minimum point, and that is what the vertex of that parabola is. So the coordinate of our vertex here, which happens to be a maximum, is going to be 1, 9. So that's the coordinate of the vertex here. How about in this guy here? The coordinate's going to be -5, -4. So now, can we tell what the maximum or minimum is going to be? Again, this parabola here doesn't have a minimum. These y values are going to continue on. This function is going to keep on going down, down, down. So there's not going to be a smallest y values possible, but there is going to be a maximum y value. So when we're asking for the max or min, we are talking about y. Remember the domain of a parabola? The domain is x as an element of all real numbers. So there is no maximum or minimum of the x values. So when asked for a max or min, when asked for the vertex, we're looking for a coordinate. But when we're asked for the maximum or minimum value, this is the y value. So in this case, the maximum is 9. It's the y value of the vertex. And in this case, the maximum is, the minimum, I'm going to put in brackets that this one was a maximum. In this case, the minimum is going to be -4. -4 is the smallest y value on this parabola. How can we find the vertex of a parabola? There's multiple ways to do this, but one way is to find the zeros or the x-intercepts of a parabola. So we can see that the zeros are right here. So I'm just going to put big dots where the zeros are. So zeros, if you're unfamiliar with that term, it's the same thing as x-intercepts. So anytime we hear the word zeros, it means x-intercepts. So where does this function hit the x-axis? And it hits right here and here. So once we find the zeros, then we just have to look exactly in between them to help us find the vertex. The vertex is going to be exactly in between the two zeros. So how can we find what's exactly in between two things? Well, we're going to find the average. So we're going to add the x-intercepts together and divide by 2. So here are two zeros, -1 and 3. Zeros are the same thing as x-intercepts. So let's find what's in the middle of them. So we're going to add them together and divide by 2. So we can see that the answer is probably going to be 1. 1 looks like it's in the middle, but let's check. -1 plus 3 is going to be 2. Divided by 2, it's going to be 1. So x is equal to 1 is what is in the middle, okay? If I were to quickly draw the line x is equal to 1. This is called the axis of symmetry. So the axis of symmetry is just the vertical line that's going to cut this parabola in half. Axis of symmetry. So it's the line that's in the middle of the parabola. In this case, because the parabola opens up or opens down, the line in the middle is going to be vertical. Okay, so this is the axis of symmetry. It's what's in between the two x-intercepts, and we know how to find in between two numbers. We're just going to add them together and divide by 2, just like what we did for periodic functions when we're looking for the line that was in the middle, but for periodic functions, it's horizontal. For parabolas, it's going to be vertical. So there's the axis. How does this help us find the vertex, though? Well, the vertex is in the middle of the parabola. So now we know one of these coordinates. So visually, I already know what the coordinates of the vertex is. But imagine if we didn't have a graph, then we know the vertex is going to have a x value of +1 because we know +1 is in the middle of these two zeros. How do you find the y value? Well, because we're given a graph, it's really easy to find out that it's 4, but imagine we didn't have this graph. Our last step to finding the vertex would be plug in that x value that we have into the equation that we're given. So let's try an example. So here's an example where we're given an equation of a parabola, but we are not given its vertex, and we're trying to, and we're not given its graph. So we have to find the vertex. We know this is going to be a parabola because if we expand this, is going to be x squared. So let's use our list that we had on this page to figure out our steps. So just as a reminder, we're going to find the x-intercepts first, figure out what's in between them, that's the x-axis symmetry, and then once we know the x value that's in between them, we can just plug that x value into our equation to find the y value. So step one is to find the x-intercepts. How do you find x-intercepts? Well, what is true for x-intercepts? X-intercepts would be along this line here, along the x-axis. And what's true all along the x-axis? Y is equal to 0. So all along here, y is equal to 0. So if you ever have to find x-intercepts, all you have to do is plug in y equals 0. Or, in function notation, f at x is equal to 0. For y-intercepts, we're going to plug in x is equal to 0. So let's find the x-intercept. So the first thing I'm going to do is I'm going to plug in y equals 0. So instead of y, I'm going to put 0 equals 2x minus 4, x plus 2. And because I am so nice, I gave this already in factored form. So we don't have to factor it. We don't have to use the quadratic formula to solve this thing. It's already almost solved for us. So now that the left side's equal to 0, can we guess these answers? Well, we know that one solution has to be that x is equal to 4. And another solution is that x is equal to 2. So we have the two x-intercepts. Let's draw them on this graph. Now this question did not ask us to sketch it, so sketching it is not necessary, but it's going to help us to visualize what it is that we're finding. So here are two x-intercepts. They're at 2 and 4. So now we got to figure out what's in between these two x-intercepts, because the line that's in between, that's what's going to give us our y value. Maybe it's super obvious to you. What's in between 4 and 2? It's 3. So if you don't need to calculate it, don't calculate it. But just for practice, because we will get ugly zeros, I'm going to calculate the axis of symmetry. So that's what's in between those x values. Okay, axis of symmetry, so we're just going to add those x values together and divide by 2. So 4 plus 2, divide by 2. 4 plus 2 is 6, divide by 2 is going to be 3. So we know the axis is 3. So here's what it would look like if I sketched it. Again, the sketch is not necessary, it's just to help you visualize what we're finding. So we know the vertex has to lie somewhere on this line. The question is, where is it? We have one clue, which is that this number here, the number that's in front, it's called the leading coefficient, is positive. So if a leading coefficient of a parabola is positive, this thing's going to open up. So the vertex is going to be down here. But actually, how to find the vertex? Well, we have to plug in the x value that we know. So we know that the vertex is going to lie on the line x is equal to 3. So I'm going to plug that into our equation. So our equation is y is equal to 2x minus 4, x minus 2. Let's practice actually with function notation just to get used to it. So instead of y, I'm going to put f at x. Okay, and I'm going to plug in 3 here. So I've got 2, 3 minus 4, 3 minus 2. Just simplifying that quickly, we've got 2 times negative 1 times 1, and that's going to give us a solution of negative 2. So that means when I plug in a 3 into this function, I get a negative 2. That's the vertex. If I were to sketch it, this is what it would look like. 3, negative 2. So we've got 3, negative 2 is right there. And this makes sense when we connect it because we knew that this parabola was going to open up, and it does. So does this parabola have a maximum or a minimum value? Because it opens up, it has a minimum value. So what is the minimum value? It's going to be negative 2. So now, can you try this one on your own? So follow the same steps that we did above and try this guy on your own. It's really important to try these things on your own instead of just following along with me, because if you make mistakes, we can correct them together. So try to find the vertex. If you don't need to sketch it, don't sketch it. Try to find the coordinates of the vertex. if you're back in the video now, you have tried to find the vertex, and we're going to take it up now. So let's take it up step by step. First, did you find the x-intercepts? And to find the x-intercepts, did you plug in y equals 0? This is essential. You can't go and pull out solutions for x here when we don't know what y is equal to. So we have to put that 0 in first, and then we can solve this equation. So because it's already factored for us, the hard work is done. So I know that my two x-intercepts are -2 and 4. What's the next step? Our next step is to figure out what's in between these two, because we know the vertex is going to lie on the line that's in between these two. So to find something in between two numbers, we just add them together and divide by 2. So x is equal to 1 is the x value that's in between these. If we were to sketch it, it looks something like this. So just to make sure that our axis of symmetry is accurate, it looks accurate. So we've got 1, 0 at -2. We've got 1, 0, or x-intercept at 4. And in between, that's going to be x equals 1. Is the vertex going to exist down here, or is it going to exist up here? Is this guy going to open up, or is it going to open down? That's the question. So taking a look at this, taking a look here, we see that the leading coefficient is negative, which means that this parabola should open down. So let's take up the next step. When you actually found the vertex, did you plug in x is equal to 1 into the equation, and did you get 4.5? If you didn't use function notation, that's okay. I'm just practicing function notation with you. So you've got the correct answer if you found the vertex, x coordinate 1, y coordinate 4.5. And the question is this a maximum or is this a minimum? It depends on how the parabola opens, and it's supposed to open down. So if you need to see this visually, the vertex is going to be at positive 4.5. So I'm going to put in a big dot here, 1 and 4.5 right there. So if we were to connect this together, this parabola opens down, which we assumed it would be. So this number here must be a maximum. And we're done. Let's do an example. We're going to put all of this knowledge together. So a soccer ball's kicked into the air. We already know this is probably going to be a parabola. Its height, h at t in meters, is approximated by the equation h at t equal to blah, 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 where t is the time in seconds since the ball was kicked. From what height is the ball kicked? So this thing is a parabola, clearly. It's going to look something, it opens down because I see the leading coefficient. Leading coefficient is going to be what's in front of the squared term. So I can see the leading coefficient is negative, so this thing is going to open down. So we've got time here, we've got height here. So it says from what height is the ball kicked? So that must mean we're looking for the initial height here. From what height? So what do we know about that point? What we know is we don't know h, but we do know t. T is equal to 0. So it doesn't say it explicitly, but we know what t is equal to. So right into the equation, I'm going to plug in t is equal to 0. So instead of h at t, I'm going to put h at 0 is equal to -5. Instead of t, we're going to put 0 squared minus 10 times 0 plus 250. And we know that this is going to be 0, this is going to be 0. Our solution is going to be 250. So we're going to write a concluding statement, because that's important because it's asking us a question. From what height is the ball kicked? The ball is kicked from a height of 250 meters. Let's try the next one. When will the ball be 10 meters above the ground? 10 meters above the ground. So now we know something about this. We know that this is 250. So where is the height 10? Maybe like here? And so we're looking for the intersection of the line y equals 10 and this parabola here. So in this case here, we're given the height. H at t is equal to 10, and we don't know what t is equal to. So let's plug in what we know. Starting with the original equation, I'm going to replace h at t with 10. So we know the height is 10. We don't know t, so leave it alone. Remember, function notation, this does not mean times t. This is a whole thing that goes together. H at t. Height is a function of time, which means that as time changes, it will change the height. The height will change with it. So how do we solve this? We've looked at for the last few weeks different techniques to solve equations like this. We could do regular solving. where we're just, I call it regular, meaning we're just going to use opposite operations. We could use factoring. We could use the quadratic formula. So can I use regular solving here? No, I've got multiple t values, so that's already out. Could I use factoring? Maybe. Could I use quadratic formula? Quadratic formula will always work. It's long. If I can factor something really quickly, I'd rather factor it, but the quadratic formula will always work. So either if we're using the quadratic formula or factoring, I got to move this 10 over. So this is going to be 0 minus 5, 0 equals negative 5t minus 10t plus 250 minus that 10. So this is going to be negative 5t squared minus 10t plus 240. So my general rule of thumb is factoring can be faster than quadratic formula. So if it looks like nice numbers, then I'm going to try factoring. And if they're not nice numbers, like we've got decimals, I'm going to immediately go to quadratic formula. So right now, it looks like I'd have to use decomposition, but because our a value is not 1, but can I take out this negative 5 out of all these terms? Yes, all of these are divisible by 5, so let's do that, and maybe something beautiful will happen. So I'm going to take out this negative 5, a common factor it out, and be left with plus 2t, and then I've got negative 48. So now I can factor this with the shortcut of decomposition. So if you wanted to do full decomposition, you could here, but we can use the shortcut of sum and product because our a value is equal to 1. So I'm looking for two numbers that multiply to 1 times negative 48. This negative 5 is not part of our factoring, what we have to factor. It's already factored out, so we're just looking here. So we're looking for numbers that multiplies to 1 times negative 48. That's going to be negative 48, and adds to 2. Are there two numbers that satisfy this? Well, I know 8 and 6 multiply to 48, and if I put a negative in front of the 6, then these two will multiply to negative 48 and add to 2. So in this case, factoring is much faster than the quadratic formula. So I'm going to rewrite this as t plus 8. This is our shortcut to decomposition that we can only use when our a value is equal to 1, and boom. So in this case, it was so much faster than quadratic formula. You could have got the same answer, but it would have taken longer. So now, I know we're squished here, but we can pull out the solution here. So the left side is equal to 0. What can t equal? T can be two different things. T can be negative 8, and t can be 6. So what was the question? When will the ball be 10 meters above the ground? So we plugged in a 10, and now we solved this thing. So we have two solutions. We have 6 and we have negative 8. The reason why we have negative 8 is this parabola is going to go all the way over here, and it should be negative 8 there. So can time be negative? No. This is what we call an extraneous answer. It's a correct answer. It is part of the point of intersection between the line of y equals 10 in this parabola, but it's extraneous in this context. It doesn't make sense. So we're going to get rid of this guy, and t equals 6 is our final answer. Let's try the next two. After how many seconds will the ball hit the ground? So what we're looking at is we're looking at this point right here, boom, right there. And what do we know about this point? We don't know the time, but we do know the height. The height is going to be 0. So we know that in this case, h at t is equal to 0, and we don't know the time. So try this one on your own. It's so important to try things on your own. Try this on your own, pause the video, come back once you've got it done. If you're back, we're checking through your answers for when you plugged in 0 for h at t. Once you plugged in 0, what did you do? Well, we can solve this with either factoring or quadratic formula. Maybe you tried factoring. If you did try factoring, you've got to take out this negative 5 first. Well, you don't have to, but it's going to make the equation a lot easier. Once you did that, you can try factoring this. Looking for two numbers that multiply to negative 50, add to 2. They do not exist. This is not factorable, which means there is only one way you could solve the problem. You had to use the quadratic formula. So you should have realized you need to use the quadratic formula. Our A, B, and C can either come from here. This one could be our A, this one could be our B, this one could be our C. So like this, A, B, C. Or it could come from this one here. This one could be our A. A could be 1, and this one would be our B, and this one would be our C. Either one will give you the same answer. An easier way to plug this in is to use these numbers because they're smaller. However, majority of you probably use these guys, so that's what I'm going to do. As you're checking your answer, ask yourself, did you put everything in brackets? Did you copy the negative, and then did you put negative 10? Because that's what it should look like, negative 10. Is everything in brackets? Check. Next, check if you simplified everything. Do you have a positive 10 here? Because two negatives, negative 1 times negative 10 is going to make positive 10. Did you find everything underneath the square root? I highly recommend that you find everything under the square root first before you square root it. Simplify it. You should get 5,100. And did you simplify the bottom to negative 10? Next, we have our two cases. For your two cases, did you have the positive version and the negative version? Everything else should be the same. And for your two solutions, you should have got negative 8.14 and positive 6.14. Again, if you're not getting that, are you putting brackets around this? This has to be done first, and then we are dividing it by negative 10. Do we have any extraneous solutions that don't make sense? Yes. X in this case is our time. So to be honest, I should have from the beginning. I know this is our quadratic equation, but we have t instead of x, so I'm just going to go through here and change this to t. We're looking for t here. This is t, this is t, this is t1, this is t2. Okay, so x is t. Time cannot be negative, so this one is extraneous. It is part of the point of intersection, but it doesn't make sense in this context. So here is our final answer. Here's our final question. What is the maximum height of the ball? I'm going to draw another picture just so that I'm not going back and forth so much, but we know that we have this sketch of a parabola. We know it looks something like this now. We know that this guy up here was 250. We know this was our height, and this was our time. We also know a few more points. We know what the X intercepts are. We know that because we just found it above. We found out when the height was 0 what t is equal to. And we found out this positive one was 6.14. That's just in the last example. And if we were to extend this out, this negative one is negative 8.14. So now the question's saying, what's the maximum height? So if I bring my cursor around here, you tell me, where does it hit its maximum? Boom, right there. What's that a fancy word for? The vertex. So whenever a question's asking you for the biggest, the smallest, because it could be a minimum too, the largest, something that indicates to you that we're talking about the biggest, the smallest, the maximum or minimum, we're asking for the vertex. So the question is, what is that height? Well, how do we find the vertex? We just did it on the previous examples on the other page. We need the zeros. We already found those. We need to find the middle of the zeros, the axis of symmetry, and plug that into our equation. So the question is, what is this middle? On those other examples, it was really easy to figure out the middle. Can you figure out the middle of these two? Well, we have an equation for it. We can find the middle. So instead of x, I'm going to put t for the middle because we're talking about t instead of x. We're just going to add them together and divide by 2. So we've got negative 8.14 plus 6.14 divided by 2. And we get t equals negative 1. What does this mean? This means your teacher gave you a question that was not a great question because the parabola actually doesn't look like this. If the middle is at negative 1, that means that the vertex is in the land of where time is negative, and this is not helpful to us. So actually, the parabola really looks like this, where the vertex is living actually in the negative time. So let's just go with it. We know that it's not going to reach its maximum. Its maximum would really be here and for positive time. So this vertex does not actually happen in on the positive x-axis. So this point right here that we just found, so we just found that the middle is at t equals -1. We just found out that that's not actually possible in this context. So, very sorry about that. However, let's just finish it off. Okay, we know that time can't be negative, but can we just practice now finding what this y value is, even though it's not possible because we're in negative time? So what was the next step that we were to do? Well, now that we know the x-coordinate of the vertex, we can just plug it in and find the y-coordinate. So we're going to plug it into our original equation. So here's our original equation. Let's put in -1. And we should get a positive number that's greater than 250 because we know that this point here was 250. So if you plug that all in, and I forgot a squared here, so don't forget the squared. Now plug it all in, and you should get 255. Okay, so we can't find the maximum other than this 250 because I've given you a question where the vertex is, that maximum doesn't exist where time is positive. However, we're still just going to practice on how to find that maximum value, and it's the same way that we did it in the other, on the other page. We're finding the zeros first. In this case, we found the zeros up here in this example, where we plugged in 0 for y, and we solved it. This case, we had to solve for the x-intercepts using the quadratic formula. Once we have the quadratic formula, then we're going to find the middle of those two zeros. In this case, it gave us -1. Now we know time can't be negative, so at this point we would be done. But we're just going to practice how would we find that maximum value after that. We're plugging in that -1 into our equation, and we're seeing what pops out for y.